Today we are going to solve the previous year questions that has been asked in GATE and IES exam from LC circuits. To know more about the theory behind these questions, you need to refer lecture number 10, that is LC circuit with and without diode. So let's start the video. Now see this question that has been asked in GATE 2009. This question is based on the concept of LC circuits. So here in this question it says that this LC circuit is given. The voltage across this capacitor, that is 10 microfarad, is 100 volt and inductance is 1 millihenry, and current through inductor at t is equals to 0 is 0. Now this switch is closed at t is equals to 0. Then in first part we have to find the current through the circuit, and in second part it says that if this circuit is used to commutate this SCR, then by closing the switch at t is equals to 0, then what is the time taken to make the SCR turn off? So we have to solve these two parts of this question, and each part is of 2 marks. So before solving this question, you must remember the LC circuit equation. So in my lecture I told you, suppose this is a LC circuit, this is source voltage Vs, this is switch, it is closed at t is equals to 0, this is inductor and this is capacitor, this is inductor L and this is capacitor C, and this was reference polarity of inductor voltage and this was reference polarity of capacitor voltage. Now the capacitor current or current through this circuit is given by I is equals to root C by L. Here inductor current is equals to capacitor current, so simply we can write I is equals to root C by L Vs minus VCO sine omega naught t. Okay, now for this circuit we clearly see that this source voltage Vs is equals to 0. So if we put simply Vs equals to 0, and what is omega naught? This omega naught is equals to 1 by root LC. Okay, so Vs is equals to 0, and what is VCO? Here the voltage across capacitor is given 100 volt. Okay, but the polarity taken for this equation is plus minus Vc, but here the polarity is plus and minus. Upper plate is charged negative, while in this circuit upper plate is charged positive. That's why we will write capacitor voltage is equals to minus 100 volt. That is initial capacitor voltage, that is VCO is voltage at capacitor at t is equals to 0. So in this equation we have to simply put Vs is equals to 0, VCO is equals to minus 100 volt. Okay, so now putting all these things, capacitor is given, capacitance is given 10 microfarad, inductance is given 1 millihenry. So simply putting we get under root, what is capacitance C? C is 10 microfarad, means 10 into 10 to the power minus 6 by L. L is 1 into 10 to the power minus 3, 100, because this minus 100 and minus minus plus, and Vs is equals to 0, 100 sine, and what is omega naught? That is equals to 1 by root LC. So 1 by under root of 10 into 10 to the power minus 6 into 10 to the power minus 3. This is C and this is L. Okay, into T. So on solving this we get I is equals to 10 sine 10 to the power 4t. So this is first part of question where current I is sine 4t. Now in second part it says that if this circuit is used to commutate this SCR, Now, how this circuit can commutate this SCR? To commutate this SCR, we need to make the current through this SCR equals to 0. And how we can make the current equals to 0? Suppose direction of current in this circuit, this LC circuit is like this. If we make this current I equals to 5 ampere, that is current through this SCR, then net current through SCR will become 0. So SCR will automatically commutate. So to make this, we have to simply put, now we will solve the second part of question. Okay, so we have to simply put 5 ampere, that is current through this SCR in this direction, is equals to 10 sine 10 to the power 4t. Okay, now we have to find the time taken to make the SCR off. Okay, so if we make this, then SCR get turned off. And what is time taken? So it is simply given by sine 10 to the power 4t is equals to 1 upon 2. So solve this, we get t is equals to 52 microsecond. So this is the answer. Now see this question that has been asked in GATE 2013, and here this thyristor is shown, and this is inductor and this is capacitor. This is inductor L, this is capacitor C, and it is this circuit is supplied with 15 volt DC. Now holding current is equals to latching current is equals to 0 for this thyristor. SCR is triggered with a single pulse of width 10 microsecond. Here inductor L is equals to 100 upon pi microhenry and capacitor C is equals to 100 upon 5 microfarad. Now we have to find the time up to which this SCR conducts. So if you go through my lecture that is diode LC circuit, then you will get the equation of current I is equals to Vs root C by L sine omega naught t, where omega naught is equals to 1 by root LC. Okay, this equation has been derived in lecture that is on diode LC circuit with and without diode. Okay, so we get the equation of current there, that is I equals to Vs root C by L sine omega naught t. Here this current is I. Okay, now we can clearly see that this current is sinusoidal. Okay, first thing is this current is sinusoidal. Second thing is this SCR, if we trigger this SCR at t is equals to 0, then this SCR get immediately turn on, because latching current and holding current are equals to 0, and it will get immediately turn off also when the polarity of voltage reverses. Okay, so this I current is a sinusoidal waveform. Suppose this is waveform of this current, and this is maximum value. Okay, we know that this positive waveform means the direction of flow of current like this from anode to cathode. Okay, but when this waveform tries to reverse, then this thyristor will not allow the current to flow in reverse direction, because after pi this direction of current reverses, and reverse direction of current means the direction of flow of current like this. But we know that thyristor is a unidirectional device, that's why it will not allow this direction of current. Okay, so we will get this current I up to pi only. So we can say that this thyristor will conduct up to pi. Now we can write, we get I naught up to pi only, and at omega t is equals to omega naught t is equals to pi, this current is equals to 0, I is equals to 0. Okay, so if we put Vs root c by L sin pi, then it is equals to 0. So we can say that omega naught t is equals to pi. This is the angle up to which this thyristor conducts. And what is omega naught? It is 1 by root LC. So time is simply equals to pi by omega naught. Or we can say that pi root LC. What is L? That is 100 upon pi. C is also 100 upon pi. So we simply get, here you can write T is equals to pi into 100 upon pi into 100 upon pi. Okay, so on solving this pi will cancel out. So we simply get 100 microsecond. Okay, so 100 microsecond is the time for which this thyristor conduct.
If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.